Deep beneath the Earth's crust, the hunt for liquid energy begins with a violent, high-pressure breakthrough. Thousands of pounds of pressure are unleashed to move the black gold from the depths to the surface.
This is a landscape of pure power, where raw earth is transformed into the world's most vital industrial fuel.
Extraction is just the beginning. The real engineering challenge is moving millions of barrels across the globe.
Structural integrity is non-negotiable, requiring micron-level precision to prevent leaks in the high-pressure network. We use sound waves to filter the crude, stripping away impurities before the oil ever leaves the extraction site. Where oil doesn't flow, we move mountains, utilizing massive-scale machinery to unlock the Earth's heaviest reserves. Science and scale work in tandem, ensuring that every barrel meets the chemical standards of the global energy market. The raw energy is harvested and purified. Now, it enters the globe. Thousands of miles are monitored from the inside, ensuring the high-pressure flow of energy never falters. Every 500 miles, we inject new force into the system, pushing the black gold across entire continents. Security is a multi-layered operation, combining aerial surveillance with real-time digital monitoring.
We control the pulse of the nation from here, managing the flow of millions of barrels with a single digital command. Automation and
precision sensors detect what the human eye cannot, maintaining a zero-failure protocol across the transit network. From the pipeline to the sea, we transition the cargo to the giants of the ocean for global distribution. Loading a supertanker is a delicate balance of physics and software, managed by the second to ensure stability. Every departure is protected by a digital shield, ensuring the safe passage of energy to the global refinery. The transit is underway. The raw crude is now moving toward its final transformation into the fuel that powers the world. Entering the world's largest energy fortress requires a digital handshake, verified by layers of high-velocity surveillance. This is the industrial frontier, a multi-billion-dollar complex guarded by the most advanced monitoring systems on Earth.
Welcome to the core. Here, every drop and every digital signal is verified against a rigid set of security protocols.
Human oversight is the final layer of defense, ensuring the high-pressure environment remains under absolute control. We monitor the pulse of millions of barrels through a digital twin, preventing any deviation from the operational blueprint. Autonomous patrols never sleep, maintaining a zero-leak protocol across thousands of acres of high-pressure infrastructure.
Verification is constant. We ensure every component is ready to handle the extreme physics of molecular separation.
The gates are locked. The system is verified. Now, the raw crude enters the
The molecular breakdown begins in the furnace, where extreme heat prepares the crude for its vertical separation.
Physics and gravity work in tandem, sorting the complex hydrocarbons by their unique boiling points. Every fraction is captured at its precise density, ensuring no energy is wasted in the primary separation phase.
What you see here is the first stage of transformation. Raw crude becoming the building blocks of modern fuel.
Precision sampling is automated and constant, ensuring the purity of every fraction by the millisecond. We strip away the corrosive elements at high speed, protecting the facility's internal metallurgy from saltwater erosion.
Lowering the pressure allows us to boil the heaviest oils without damaging their molecular structure.
Verification at every stage ensures the raw fractions are ready for the high-pressure chemical reactions ahead. The crude is separated. The molecules are sorted. Now, the structural assembly of the final fuel begins. We break the heavy chains of carbon at the molecular level, reconstructing the chemistry of the fuel. Precision control of the catalyst flow is the heartbeat of the refinery, maintaining the delicate balance of the reaction.
This is the chemical core, where heavy residues are reborn as high-value gasoline and aviation fuel.
We don't just create fuel, we capture the energy of the reaction. Efficiency is found in the recycling of heat and pressure.
Every sound tells a story of molecular motion, verified by technicians who monitor the pulse of the machine. We strip away the sulfur at the molecular level, ensuring the final fuel burns clean and meets global emission standards.
Nothing is wasted. Even the impurities are reclaimed and transformed into raw material for the chemical industry.
The raw components are now ready, verified, for the final assembly of the world's highest grade fuels. The molecules are broken. The impurities are gone. Now, the final integration of the fuel system begins.
We integrate the final chemical DNA, ensuring every drop meets the high-performance standards of modern engines.
Precision logic governs the flow, managing a complex web of distribution with microsecond accuracy.
This is the nervous system of the refinery, where the power of the grid is converted into the movement of energy.
Is efficient. Real-time calibration allows us to adjust the fuel's performance profile without ever stopping the flow.
Visual identification is built into the chemistry, providing an instant layer of quality verification for global logistics.
The digital and physical worlds are perfectly integrated, ensuring the fuel remains secure within the system's logic. Mathematical certainty is the final filter, verifying that the molecular assembly is structurally complete.
Every mechanical heartbeat is monitored, ensuring the facility operates at the peak of industrial efficiency.
The systems are integrated. The fuel is perfected. Now, the robotic heart of the facility.
Molecular fusion creates a unified high-pressure artery, capable of withstanding the violent surges of millions of barrels.
Aerodynamic internal flow is critical. Every weld is smoothed to prevent turbulence in the high-velocity fuel stream.
This is the forge of the modern world, where massive scale meets the precision of automated robotics.
We manage heat at the structural level, ensuring the integrity of the system remains absolute under extreme operation.
Internal flaws are impossible to hide. Every structural bond is verified by high-frequency sound waves in real time.
Symmetry is the key to stability. The control surfaces are unified with the airframe to ensure a flawless structural seal. We use kinetic energy to bond the structure, creating a seamless connection that survives the shock of industrial operation. Every joint is hermetically sealed, protecting the internal logic from the corrosive environment of the refinery complex.
The structure is fused. The machine is whole. Now, it receives its final tactical skin for the industrial battlefield. Surface preparation is a precise science, ensuring the protective tactical skin bonds perfectly to the high-pressure frame.
We apply a molecular shield, protecting the core infrastructure from the harsh, corrosive environment of the refinery.
This is where the machine receives its identity, a specialized finish engineered for extreme durability and thermal resistance.
Our tactical finish is a specialized polymer designed to make the infrastructure nearly immune to saltwater and chemical erosion.
The industrial skin is engineered for survival, allowing the system to maintain its integrity under Mach 3 fluid friction.
Heat locks the tactical identity in place, ensuring the coating survives the thermal stress of high-octane chemical reactions. Thermal management is integrated into the finish, protecting the structural integrity from the extreme friction of the internal flow.
Every component is an authenticated asset, tracked digitally from the refinery floor to the global dispatch network.
The hide is complete. The machine is dressed for service. Now, the system must prove its resilience in the simulation.
We subject the assembly to extreme acoustic stress, ensuring every electronic bond remains intact during high-pressure fluid flow.
From freezing environments to the heat of chemical friction, the system is engineered to remain operational in any climate.
Performance is verified in a digital vacuum, ensuring the control brain neutralizes surges with mathematical certainty.
Our autonomous logic is hardened against the most intense electronic interference of the modern industrial landscape.
The system is hermetically sealed, protecting the sensitive logic processors from moisture and salt air ingress. Hardened against the unexpected, the machine maintains its operational profile even under direct electromagnetic interference. Perfect balance is essential for industrial stability, preventing any deviation during high-velocity fluid transit. Energy management is verified, ensuring the system has the power surge required to finish the mission. Tested, proven, perfected. The transition from raw material to a high-security energy asset is complete. Every component is hermetically sealed in a climate-controlled environment, ensuring it remains in peak condition until the moment of installation.
Logistics and security are integrated into a single digital thread, tracking the asset from the refinery floor to the global fleet.
Thousands of units are staged in a state of constant readiness, a silent deterrent housed within a mountain of steel and concrete.
The transition is complete, from raw minerals to the most advanced energy infrastructure in the world.
Total asset integrity is guaranteed, ensuring the technology remains untouched throughout its journey to the maritime theater. Every shipment is a coordinated operation, protected by layers of physical and digital security until it reaches the destination. The factory continues its silent work, forging the next generation of precision-engineered industrial systems. In the world of high-stakes industry, the factory is the ultimate frontline, building the systems that change the global balance of power.
Subscribe for more real industrial breakdowns.